All right, so we are going to start on Chapter 1, Section 1 for IM2. This is called Adding and Subtracting Polynomials. This one has a couple of pages for the notes, so we'll go through each one here. So the first one is just introducing the idea of a polynomial. So they give us a definition. A polynomial is a monomial or the sum of monomials, each called a term of the polynomial. Some polynomials have special names. A binomial is a sum of two monomials, while a trinomial is the sum of three monomials. So they're definitely throwing out some words here. So let's take a look at them. If we kind of break these down, whenever you see nomial, it means number. So whenever we hear that part of a word, we know that it means a number. And then if we break down the other pieces, so poly means many. And this is just kind of the root word. So polynomial means many numbers. If we look at these other pieces, so we have nomial again, so we know we have number. Whoops, don't know why I put an M there. Number. And then mono means one. So this means one number. And here's an example of one number, 5x. So there's a lot of different options when you're talking about monomials. You could have just a number, you could have just a variable, or you could multiply numbers and variables. So there's a couple of rules we can't break when we're doing monomials, and I'll explain that in a minute. So if we still have number on this one, but now we have by on the front, that means two. So this guy would mean two numbers. So whenever you see addition or subtraction, and sometimes division, I'll explain the sometimes division. Although no, that would be a polynomial, so not division, just addition or subtraction. With two pieces, that's a binomial. It means we have two pieces, so two numbers. Tri means three, and monomial again means number, so three numbers. So now we have 1, 2, 3 different numbers, and we can see there's a plus sign between each one of those terms that creates another number, and it can be plus or minus that creates the separation there. And we've heard these words before, monopoly, bicycle, tricycle, right? Things like that. So we've heard these words before, generally just kind of used, but now we're applying them to mathematics here. So the next piece says a degree of a monomial is the sum of the exponents of all the variables. An example, it says, thus 5x is first degree, because 5 is 0 degree, so the 5 here has a 0 degree, and x squared is second degree. Oop, I think they just meant x is first degree. That was just a typo there, first degree. Because we're talking about 5x here. They accidentally did x squared when they typed this up. So this has a degree of 1, meaning it has an exponent of 1. And 5, we don't really say it has an exponent of 0. That's not what we're saying. It just has a degree of 0 when we're looking at the number. So we would add these two together and we get first degree. Take note that XYZ is third degree by definition. And the reason is because each one technically has the exponent of 1. So we'd go 1, 2, 3, third degree. All right. The degree of a polynomial is the greatest degree of any term in the polynomial. Polynomials are named based on their degree. So we put them in order from greatest to least. That's the best way to identify what the degree of the polynomial is. So let's go ahead and look at these first four. They actually have the answers attached here so we can review. So we have 4y minus 5xz, and that's a dash, not another minus. And they're saying, yes, this is a polynomial, and it's a second degree, and it's a binomial. So they're giving us a couple of different pieces here. So the reason we say it's a second degree is, remember, the 4 has a 0. It's 0 degree, not a 0 exponent, 0 degree. The y has a 1. Now, if we look at the 5, and I'll just write it over here, 5xz, we'd have 0 degree, we'd have 1 and 1. So I can actually, the only problem with writing a 0 here, I don't like this. This isn't a 0 exponent for this guy, it's just a 0 degree. And then these guys, we do look at their exponents, which would be 1s. So now we have 1, 2, and then 0. So we have a second degree is bigger than 1 degree here because we have 0 plus 1. So that's why it's a second degree. And then we say it's a binomial because there is a minus sign here in the middle, right? Which makes two terms, two numbers. Remember, binomial means two numbers. Bi means two, nomial means number. All right, so if we look at this next one here, and remember, this is number 1, number 2. This isn't actually part of the problem. So our number is negative 7.5. And they go right off the bat and say it is a monomial. So they just didn't say yes, but yes, it's a monomial. It's just it's a number with 0 degree. Remember, if it's just a number, just like 4 and 5 here, this has a degree of 0. Only exponents or variables are the exponents that we're looking at that have a degree more than 0. All right, number 3, we have 7x to the negative third. And then they change it here to, it actually equals 7 divided by x to the third, or x cubed. And the reason for that is what this exponent means right here. When I have a negative exponent, it doesn't actually mean it's negative. What it means is it's in the wrong spot. That's actually what a negative exponent indicates to us. And what I mean by spot is that all numbers are fractions. They all have a 1 under them. We just wouldn't write them like that because it would get kind of confusing and crazy looking. But it's there. We always have a fraction where we can divide by 1. All numbers have that there. So if you see a negative exponent, what it means is that it shouldn't be up here on the top in the numerator. It should actually be in the bottom, which is why they rewrite it like this. And now once I move x cubed down, it's no longer negative. I no longer have to indicate it's in the wrong spot. Now it's in the correct spot. It's in the denominator. So the negative drops away. So that, I know that's a little different than normally when we look at a negative number. It truly means that it's negative. But in this case, it's just an indicator that it's in the wrong place. I say it that way. That's kind of a funny way to describe it, but that's how I like to describe it. So it is not a monomial, and they don't explain necessarily. The reason is we are not allowed to have an exponent in the denominator when we're talking about monomials. We're only looking at multiplication or single pieces. So like up here, it could have been 5, it could have been x, or it could be 5x because it's 5 times x. Any of those are fine. We can also square a variable or cube it or however we'd like. But once we start dividing by the variables, then we're changing this because now it becomes more along lines of two terms than it does a single number or one number. You can have, like if this were flipped, this would be a monomial. And the reason is because we can look at this as 1/7 times x to the third. So it's really a number times a variable cubed. That's another way to write this version. But because we have the variable on the bottom, that changes things. That is not a monomial. Either way, if you have a negative exponent on a variable, that's automatically not, because it would move the variable down to the bottom. Or if you start with the variable on the bottom, then no, it is not. So this is kind of a practice in both issues where we would not have a monomial. All right. So now we have 6x squared minus 5x plus x plus 3 is a trinomial with a second degree. And they say trinomial, which means 3 numbers, but I see 4. So what they did was they took these like terms in the middle and they combined them. So we would have 6x squared. I don't want to make sure that's a plus sign, right? I just crossed it off a little bit. Plus 5x plus x. Remember, this is 1x. So I have 6x in the middle plus 3. So now I have a trinomial because there's 3 numbers, and second degree because it's looking at this term, which is the biggest one, it has the most, or the biggest sum for the exponents, because we have a 0 degree, and then we have not second degree, but second exponent there, or 2 to the second power. So 0 plus 2 is 2 second. All right, so now if we look at number 5 and number 6, and I know they're kind of at the bottom here, but number 5, we have x squared plus 1 divided by x plus 5. And because this doesn't have parentheses here, if this had parentheses, it would mean it would be divided by the entire thing, x plus 5, which is a binomial in itself. We also have plus signs here, so there's a couple indicators why this is not a monomial. So this would be 3 pieces at least, because we have x squared, 1 divided by x is another piece, and then 5 is another piece. So this is definitely not a monomial. It's not one number. But we also have an x as a denominator here, 1 divided by x. So there's a couple of different indicators why this is not a monomial. There's more than one reason that you could state. So this is not. I'm just going to write not next to it. So not a monomial. All right, so this guy, if we combined our like terms, we have 10x minus 4x. They both only have an x. It's the same variable with the same exponent. I can combine these guys, so we end up with 6x here. So this is a monomial for definitely. This only has oh, it's interesting. This one I just noticed we were naming all of these other ones for not monomial. So technically this guy we would say not monomial, but they went ahead and instead of saying yes, it's a polynomial, they just went ahead and named it trinomial. Sorry, different wording there. I just noticed that between the two problems. So we have a monomial. It's one number because it's a number times a variable. That still counts as one number. And the degree here, because 6 has a degree of 0, x has a degree of 1, so it's a first degree monomial. Boop, just like that. All right. So let's go ahead and go to the second page here. This is still lesson 1.1. It's kind of cutting it off a little bit, but so now we're going to practice putting them kind of in order and looking at the pieces here. So we have the standard form of a polynomial has the terms in order from greatest to least. In this form, the coefficient of the first term is called the leading coefficient. So you can see this is from least to greatest, and what it means is we want to order them by exponent. So x cubed is bigger than x squared, which is bigger than just x, which is bigger than no variable at all. So the constant always goes on the end. Constant means just the number by itself. Okay, so we want to put them in order. We're not always going to have it nicely where it's x cubed, x squared, x, which would be 1. So there's 3, 2, 1, and then nothing. We're not always going to have every single piece, but we want to put them in order from least to greatest in this way. So if we look at this one down here, we have x cubed minus 5x plus 7x to the 4th power. So 4 is bigger than 3. So we want this 4, and I keep backing up here, but I'm going to go ahead and put it up here so I have more room. We want this to be our first term because this is bigger. And then if I go to the next piece, it would be the cube. So I'd have plus, because since there's nothing in front of it, I know it's a positive x cubed. And then we would write minus 5x on the end. And there is no constant here. There was no squared term. So this is in order. Our leading coefficient is 7. And the degree is going to be 4. Okay, so this is what Alex may ask you to do. It kind of depends on the problem, but they may ask you to type out the standard form, so from greatest to least. They may also ask you what's the degree of the polynomial, or what is the leading coefficient of the polynomial. If they're asking you for kind of a longer answer that has multiple pieces, it'll probably be in a drop-down form. So you'll just click drop downs and choose the correct ones. You just want to make sure you put them in order. This is just a practice for the next couple of steps, also for the next couple of pages, because it's important that they're in order so that they line up correctly when we go to combine them with other polynomials. All right, so let's go ahead and practice this one. So we have y plus 2y squared plus y cubed plus 4y to the fourth power. So 4 is my biggest exponent. I'm not talking about the number 4 on the front here. I'm not talking about this coefficient. I'm talking about this exponent 4. So they brought chance both 4 there. So then the next step down would be cubed. So I have y to the fourth, y to the third, or y cubed, and then can step down to the second power and then step down all the way just to 1, which we don't have the 1 there. It's never written, but it's there. It's always assumed that it's there. So we went 4, 3, 2, 1. We're going in order, yay. So our leading coefficient is 4. Our degree is also 4 in this case. All right, let's go ahead and look at page number 3. Same one, it's just kind of cutting it off here. So this is still section 1. Now we're looking at add and subtract polynomials. So adding polynomials involves adding like terms. You can group terms using horizontal or vertical format. So let's go ahead and look at both of these formats. Horizontal, this tends to be the method I use pretty often, but vertical is not a horrible option. We will go through and take a look at that. I want to show it to you because it's definitely a different way to look at it than, students have gotten used to looking at these types of problems. So we're given this problem here at the top. And the vertical format, and I like this one. If you have the printed notes pages, probably not in color, but you can see it on here. We have a color coded. So they have 2x squared and negative 4x squared, both red. And when I'm reading it as just one term like that, I say negative 4x squared. But when I read this together, if I actually read it the whole thing, I'd say 3 minus 4x squared. So minus and negative are the same thing. It just depends on the situation you're looking at it. If you're looking at a single term, you would say negative 4x squared. But once you're reading it as a sentence, you read it as minus. I bring that up because it actually came up in class on what the difference was, why I would say minus instead of negative. And then 5x and 6x, they're both positive, but they're both blue. So those are like terms. And then negative 7 and 3, those are also like terms, and they are green here. So they kind of color-coded the like terms for us so we could see them. And then they regrouped them in the second step, which means that they brought them together. So here are our two x squared terms brought together, and they put a parenthesis around this one so that we know that it was negative. And then they brought the x terms together and then the constant terms together. So they're just grouping them for us. I know a lot of the time students kind of do this step in their head. They don't tend to write this one out, but it's not a horrible idea to write them out to make sure that you've grouped them correctly. Definitely shows your work a little bit better there. And then the last step is to just combine. So we have 2x squared plus negative 4x squared. It means 2 minus 4, so negative 2. Whenever you have a positive and a negative, you subtract, and the bigger number, which in this case 4 is bigger than 2, decides our sign. So that's why it's negative 2. We have more negative than positive. And then this is, 5x plus 6x. We just add those two guys together because they're both positive, so we get 11x. And then negative 7 plus 3, so again, negative, positive, we subtract. 7 is bigger than 3, so I have negative 4 instead of positive 4. All right, so that's the vertical method. They're just going across. Not vertical. That's the horizontal method because that's going across from left to right. Vertical method, so now they give us another problem here. And what they're showing is they're stacking it. So one on top of the other. And this is just like you would do if you had something like this. So this is like kind of applying the same rules that we would use for just constants if we were adding them. So I would add straight down. I'd go 2 plus 3, I'd get 5. 4 plus 1, I get 5. And there's my answer. So I can do the same thing with polynomials. I just have to make sure that they are in order from least to greatest. So you can see they reordered these. So this first one, it did start with 3y plus y cubed minus, I believe that's 5, yeah. Sorry, it's a little blurry on there, but down here I can see definitely it's 5. So now it says y cubed. So they brought this middle term to the front because that's our leading. That's our degree, right? Because it's our biggest exponent. And then they did plus 0y squared. because there is no y squared in here, but there is one in the second piece. So in order for them to line up correctly, we want to show that that is kind of a zero placeholder. It's not really there, but it's just holding a place. And then we have 3y minus 5, and then they went ahead and lined up the second one. And again, they ordered it from greatest to least. So now this is the first term down here, and then this is the second term, third term, and fourth term. So they went in order, 3, 2, 1, no exponent here, right? So now I can just add straight down. I have negative 5 plus 8. One's negative, one's positive. I subtract. 8's bigger than 5, and it's positive, so my answer is positive. 3y minus 4, again, just another practice in positives and negatives. Excuse me. Because negative 4, or 4 is bigger than 3, I have one extra negative, so negative y. 0 plus 4 just gets us 4. And then y cubed plus 2y cubed. So remember, there's a 1 here. Whenever you don't see the number, it's a 1. So 1 plus 2 gives us 3. So it's just a different way of looking at the numbers. But either way is still very valid. It just depends on how you like viewing it. So we're going to practice the horizontal method on the first one. And then we will practice the vertical method on the second one here. So if I go across the horizontal method, we want to group our like terms. So I'm circling these two because they both have an x squared on them. So I have x squared plus 5x squared. And I'm going to put brackets around it just like they did up here. And then plus, now I have, and here I'll even change colors, 5x minus 2x, or negative 2x. So I have 5x plus negative 2x, and then I'll go back to red here just so that it's consistent, kind of ending there since I started with that. All right, so now we're going to start working these out. So remember, this is a 1x plus 5x squared. They're like terms, so I can go ahead and add them together. Get 6x squared plus, now I have 5x plus negative 2x, so I'm going to subtract. It's 5 minus 2. I get 3. And because 5 is bigger than 2 and it's positive, it's going to be a positive 3. So there we go. I've combined them horizontally. So, going across left to right. So now if I look at this one, I'm going to line them up. So I have 6x squared plus x. They were already in order because I have squared and x. And then this one is not in order. I need to make sure I put it in order. So I have negative 2x squared here plus 5x. So I just I switch their spots, but that negative or that minus follows the 2. It actually belongs to that 2, so always keep that in mind. Whatever's in front of it, whatever symbol's there, belongs to that number. So now it's not minus 2x, it's negative 2x plus 5x. And we're going to add that together here, and they put that in parentheses for whatever reason to show you that it was kind of the front part here. So now I'm going to add straight down. So I have x plus 5x, and then 6x squared minus 2x. It's really plus negative 2x, but 6 is positive, 2 is negative, so I'm going to subtract. I get 4x squared, and then it's going to be positive because 6 is bigger than 2 and it is positive. So I have more positive than negative. All right. So we are going to practice one more screen and then we'll be all done with section 1. Sorry, there was a lot of pages for section 1 here. So it's the exact same idea for this last page, except now we are looking at subtraction. So before, in this symbol in between was an addition symbol. Now we're looking at subtraction. So this does affect the problem a little bit. And the reason it affects the problem a little bit, and you can see this in the example, so we still have the horizontal method, we still have the vertical method. But what they do with this negative is they take it and they distribute it here, meaning that everything inside of the parentheses there changes sign. So it was positive 4x, now it's negative 4x. It was negative 5, now it's positive 5. It was positive 3x, now it's negative 3x. And then they turn this into a plus sign. because we have to keep in mind that when there's a negative in front of the parenthesis, it's going to change everything inside of that parenthesis. It's basically a -1. That's what it is. We have to distribute that -1 so that we can then add. So same thing here, but they have the minus here, which you can subtract straight down. It's just kind of sometimes difficult to remember that you have to apply that negative. So it's easier if you change it to a plus sign, and really what you do is it's just going to switch all the signs. We have positive 3p squared, now we have negative 3p squared. Negative 9p changed to positive. Positive 2 changed to -2. So it makes it much easier to just add straight down than it does to try to apply that negative each time. Most of the time, if you don't switch it, students tend to forget at one point to apply that negative sign. All right, let's go ahead and practice this so we can be all done. So we have x squared plus 2x squared. So there's my first grouping, plus, I'll switch it to blue again here, x and -2x. Oh, and you know what? I've already skipped over and totally forgot to apply the negative sign there, didn't I? So I need to distribute that negative sign there so that that plus makes sense. So this should not be a plus anymore. It should be a negative. Sorry, I know I'm scribbling that out. It looks a little ugly, but it's x squared minus 2x squared. And now when we do this one, so again, we're applying that negative here. So this is a -2x. This is still a positive because there's no negative in front of here. It doesn't change anything. So this is still positive x plus -2x. Oop. Changing colors here. All right, so now x squared minus 2x, we subtract. It's 1 minus 2. So we have 1, or just x squared. We don't really need to put the 1 on there. But since 2 is bigger than 1 and it's negative, it's going to be -x squared. And then we have, again, 1x plus -2x. So it's the same exact situation. Now we just have x, so it's going to be -x. You can put plus -x, but Alex is going to want you to simplify that so that you don't have the extra parentheses there. All right, let's go ahead and look at this guy. So 3y minus 2y. So this is already in order, but remember, we need to distribute that negative sign, okay? So I know they wrote it first here. I'm distributing it, and then I'm going to write it with just the plus sign. So it's -2y, -5y cubed. So -5y cubed, because that would go, that's the bigger one, minus 2y. And I can draw my line, and I have my addition symbol because I applied that negative. All right, so we have -2y minus 2y. They're both negative, so I add, and I keep the negative sign. Basically, I already have 2 negative, and I'm going 2 more negative. So 4 negative. All right, +3 plus -5. So there's 1 positive, 1 negative. I'm going to subtract. 5 is bigger than 3, so it's negative because 5 is negative. And then I put that on there. So there we go. We did section 1. I know that was a very long video because there was 4 pages there. So the next one will definitely be a little bit shorter, and I will see you in section 2.